From machines that can work thousands of acres in a single season, operate 20 hours daily, to replacing entire crews that once numbered dozens. Here are the top 15 biggest agricultural machines. Number 15. High-capacity self-propelled sprayers. Modern self-propelled sprayers look simple, but they quietly changed farming. Machines like the John Deere R4150 or Case YH Patriot 4450 are built around one idea: cover more land in less time. Power matters, but width matters more. These sprayers run engines around 400 to 450 horsepower, yet their real strength is the boom. Many stretch 36 to 40 meters wide, wider than most highways. The tanks are just as extreme. A typical high-capacity sprayer carries 4,500 to 5,000 liters of chemical. One pass can treat dozens of acres in minutes. Fewer passes mean less fuel, less compaction, and fewer operators. That is the payoff. But there is a trade-off. At this scale, mistakes are expensive. A small calibration error can burn crops across entire fields. Prices reflect that risk. Number 14. Bigger sprayers, bigger problems. As sprayers grew wider, engineers pushed limits. A fully loaded sprayer can weigh over 25,000 kilograms, pressing hard on soil. That pressure can reduce yields long after spraying is done. This is where precision fights destruction. Bigger sprayers save time, but they also increase the risk of overlap, drift, and soil damage. Laws now restrict how wide machines can travel on public roads, forcing complex folding systems that raise costs and maintenance. Some regions cap transport width near 3 to 3.5 meters, even when field width is 10 times that. Because of these limits, sprayers are often the first machines to go autonomous. Straight lines, repeat routes, and high accuracy make them ideal for automation. And once width stops being enough, engineers start chasing something else. Number 13. John Deere DB90. The John Deere DB90 is where planting stopped being a manual skill and became a systems problem. This planter can run up to 36 rows, covering a working width of about 27 meters. Behind it are individual row units, each controlled separately. Every seed is measured, timed, and placed with precision that no human could match consistently. Planting accuracy matters more than people think. A seed placed even 2 to 3 centimeters too shallow or too deep can affect emergence and yield. At scale, small errors multiply fast. On a 1,000-acre farm, uneven planting can cost lakhs in lost output. That is why the DB90 relies on downforce sensors, hydraulic control, and GPS guidance accurate to 2.5 centimeters. The planter itself does not have an engine. It depends on large tractors pushing 400 to 600 horsepower just to stay stable. Fully loaded, the DB90 can weigh over 20,000 kilograms. Thousands of seeds are placed every minute, evenly spaced, at the right depth. But when one row unit fails, the system keeps moving, sometimes planting wrong for acres before anyone notices. And that becomes a serious problem at this size. Number 12. John Deere DB120. It takes everything about the DB90 and stretches it further. With up to 48 rows and a working width close to 36 meters, it can plant fields faster than most farms can prepare them. In perfect conditions, it plants like a machine-built grid, not a field. To make this possible, the folding system becomes critical. The DB120 folds into transport mode using multiple hydraulic joints, locking pins, and sensors. Fully folded, it still pushes the limits of road laws. Most regions allow a maximum transport width of 3 to 3.5 meters, which makes moving this machine slow, risky, and expensive. Weight is another issue. Fully loaded, the DB120 can exceed 25,000 kilograms, increasing soil compaction, especially in wet conditions. That compaction can reduce yields for years. This is why some farmers say the planter saves time up front but demands discipline later. One failed row unit, one GPS error, or one transport mistake can erase the gains of scale. Planting at this level looks impressive, but compared to harvesting, this is still the easy part. Number 11, air seeders. Air seeders changed planting by removing gravity from the process. Machines from Bourgault, Seedmaster, and Vaderstad use high-pressure air to move seed from large tanks to each row. Instead of seeds falling down tubes, they are pushed with controlled airflow. That one change allowed machines to grow far wider than traditional planters. A typical large air seeder system works with toolbars 15 to 24 meters wide, sometimes more. Seed and fertilizer tanks can hold 10,000 to 18,000 liters combined. These systems are usually pulled by 500 to 650 horsepower articulated tractors. Fully loaded, a complete air seeder setup can weigh 30,000 kilograms or more. The reason large farms prefer air seeders is consistency. Air pressure keeps seed flow even across long distances. Missed rows or uneven spacing across hundreds of acres can mean serious losses. GPS guidance keeps accuracy within 2 centimeters, even at speed. Number 10, massive toolbars. But as the air seeders grew, toolbars became the real challenge. A toolbar is the wide frame that carries openers, hoses, and depth controls. On the biggest systems, toolbars can stretch beyond 24 meters, carrying dozens of ground contact points. Keeping that frame level across uneven ground is difficult. This is where size meets resistance. Steel flexes. Hydraulics strain. A fully loaded toolbar must stay flat to within a few centimeters, or planting depth becomes uneven. That is why these machines use complex suspension systems, active downforce, and multiple hydraulic circuits. Each system adds cost and maintenance. Air seeders dominate large farms because they scale well. But even they face limits. And seeding, heavy as it is, still weighs less than what comes next. Number 9, sugar beet and potato harvesters. Root crop harvesters are some of the heaviest machines used in agriculture, and for good reason. Crops like sugar beet and potatoes grow underground, packed tightly in soil. Machines such as the Holmer Terrados and large Grimm harvesters are built to dig, lift, clean, and store these crops in one continuous process. Take the Holmer Terrados as an example. It can weigh over 30,000 kilograms empty and more than 50,000 kilograms when fully loaded. It carries engines producing around 650 to 700 horsepower, not for speed, but to move weight steadily without stopping. The onboard bunker alone can hold over 20 tons of harvested crop. That means fewer unloading stops and higher daily output. What makes these machines impressive is not just size, but control. Before machines like this, harvesting root crops required large crews. Dozens of workers would dig, collect, and load crops by hand. Today, one operator can harvest what once took days of labor in a single afternoon. Even so, as large as these machines are, grain harvesters would soon grow even bigger and far more dominant. Number 8, Class 9 combine harvesters. Class 9 combine harvesters marked the point where grain harvesting became a continuous industrial process. Machines like the Class Lexion 8800 are built around one priority: move grain through the machine without slowing down. These combines typically run engines producing 650 to 700 horsepower, not to go faster, but to keep internal systems moving under heavy load. Headers on Class 9 machines commonly range from 12 to 15 meters wide. At that width, crop volume increases faster than ground speed ever could. Grain tanks usually hold 13,000 to 14,000 liters, allowing longer runs before unloading. Fully loaded, these machines can weigh close to 30,000 kilograms, which is why many operate on tracks to reduce ground pressure. Throughput is the real measure of performance. In good conditions, Class 9 combines can process 80 to 90 tons of grain per hour. That level of output puts stress on the front of the machine first. Headers face uneven crop flow, stones, and ground contact. This is why they often fail before engines or threshing systems. But pushing beyond this level leads to machines that operate at an entirely different scale. Number 7. Class 10 Combine Harvesters. Class 10 combines are built for farms that cannot afford to stop. Machines like the Class Lexion 8900 and New Holland CR 10.90 represent the highest production level currently in commercial use. These machines run engines producing 750 to 790 horsepower, with the CR 10.90 rated at around 775 horsepower. Headers can stretch from 15 to 18 meters wide, feeding enormous volumes of crop into the machine. Grain tanks exceed 14,000 liters, and unloading augers can move grain at rates over 150 liters per second. At peak efficiency, Class 10 combines can process 100 tons of grain per hour or more. Fully loaded, these machines can weigh 35,000 kilograms or more, even with tracks. Soil compaction becomes a serious concern, especially in wet fields. At this point, size is no longer limited by power. It is limited by material flow. Grain must be separated cleanly, straw must move evenly, and losses must stay low. Keeping them moving requires support machines built almost as large as the combines themselves. Number 6. Forage harvesters. Krone Big X 1180. Forage harvesters are built for one job, and they do it at a scale few machines can match. The Krone Big X 1180 is the most powerful forage harvester currently in production. It runs a V12 engine producing around 1,156 horsepower, and almost all of that power goes straight into processing crop, not moving the machine. Unlike combines, forage harvesters do not store material. They cut, chop, and throw it directly into trailers driving alongside. That means everything must happen instantly. The Big X 1180 can process over 400 tons of forage per hour under ideal conditions. To do that, it spins massive chopping drums at extremely high speeds while pushing dense material through compression systems. This is why forage harvesters need so much power. Wet maize, grass, and silage are heavy and resistant. Cutting length must stay precise, often within a few millimeters, to ensure proper fermentation for livestock feed. If chop length is uneven, feed quality drops and storage losses increase. But processing forage is only half the job. Moving that volume of chopped crop requires another monster altogether. Number 5. Grain carts and support giants. Grain carts exist for one reason: to keep combine harvesters moving. As combines grew larger, stopping to unload became too expensive in terms of time and lost output. Grain carts solved that problem by turning harvest into a continuous flow operation. Modern high-capacity grain carts can hold 2,000 bushels or more, which is roughly 50,000 liters of grain. Fully loaded, a cart like this can weigh 40,000 to 45,000 kilograms, depending on grain type. Moving that weight requires large tractors producing 500 to 600 horsepower, often on tracks or oversized dual wheels. These machines are not built for speed. They rarely exceed 25 to 30 kilometers per hour. Stability matters more than pace. High flotation tires or tracks spread the load to reduce soil compaction, but the risk remains. And as machines continued to grow, tractors themselves crossed into an entirely different category. Number 4. Articulated megatractors. Articulated tractors were built when regular tractors simply ran out of grip. Machines like the versatile four-wheel drive series and large case YH Steiger models are designed to pull the widest and heaviest implements in agriculture. These tractors typically produce 500 to 600 horsepower, but raw power is not the main advantage. Traction is. Articulation allows the tractor to bend in the middle, keeping all wheels driving and turning together. This spreads weight evenly and reduces wheel slip. Fully ballasted, these machines can weigh 30,000 kilograms or more, pressing firmly into the soil to transfer power to the ground. These tractors are used for deep ripping, large-scale tillage, and pulling air seeders and toolbars wider than 20 meters. Fuel consumption is high, but efficiency comes from scale. However, soil compaction becomes a concern. Repeated passes with heavy-wheeled tractors can compress soil layers deeply, affecting root growth for years. That trade-off pushed the industry toward another solution. Number 3, tracked mega tractors. Tracked tractors change the rules. Machines like the Case IH Quadtrac 620 Plus and the Challenger MT series replace wheels with 4 independent tracks. Horsepower climbs to 620 and beyond, but the real gain is ground contact. Tracks spread weight over a much larger area, reducing pressure per square centimeter. A Quadtrac 620 Plus weighs around 28,000 to 30,000 kilograms, yet often causes less surface compaction than wheeled tractors half its size. This makes them ideal for wet or sensitive soils. Pulling capacity increases, slip decreases, and fuel use becomes more predictable under heavy load. These tractors do not pull implements. They dominate them. Toolbars stay level, depth stays consistent. Productivity rises, but ownership is rare. Tracked mega tractors solved many problems. But one tractor went further than all of them, proving just how big agricultural machines could really get. Number 2, Big Bud 747. The Big Bud 747 was built to solve one problem on one farm. In 1977, a large cotton operation in the United States needed a tractor powerful enough to pull an enormous cultivator across vast fields in a single pass. Standard machines were not enough, so engineers built something no one else dared to. Big Bud 747 produces around 1,100 horsepower, even by modern standards. It weighs over 45,000 kilograms and rides on 8 massive tires, each nearly 2.4 meters tall. The tractor is over 8 meters long and 6 meters wide. At full load, it could pull implements wider than 24 meters, covering more land in one pass than entire farms once managed in a day. The engine was originally a 16-cylinder Detroit diesel, chosen for durability rather than speed. Big Bud rarely moved fast. It did not need to. Its job was steady, unstoppable pulling power. And it worked. It reduced field passes dramatically, cut labor needs, and delivered exactly what the farm demanded. Big Bud was never mass-produced because it solved its problem too well. It worked perfectly. And that is why it scared manufacturers. Because once it existed, everyone knew the ceiling was not technical at all. Number 1, industrial-scale combines. The largest agricultural machines today are not defined by one model name. They are defined by a direction. Industrial-scale combines represent the peak of size, capacity, and coordination in modern farming. At this level, combines operate as part of a system. A top-end combine may produce 750 to 800 horsepower, carry grain tanks exceeding 14,000 to 18,000 liters, and run headers wider than 18 meters. But the combine alone is only one piece. Grain carts, trucks, GPS networks, yield mapping, and real-time data all work together to keep it running without stopping. Fully loaded machines can exceed 35,000 kilograms, even with tracks. One delayed truck or one blocked cart can slow an entire harvest operation. That is why these machines are planned around logistics, not just field work. But what do you think? Are these machines the future of farming or its limit? Let us know in the comments and watch our next video on the world's biggest industrial machines.